This is Physics in Minutes. This episode, Matter of States, Part 3, Bending the Rules. We know that matter will change state depending on the temperature and/or pressure. For example, did you know you can convert gaseous oxygen into a nonmetallic solid at room temperature? Just apply 10 gigapascals of pressure, and it's easy. But let's begin by quickly re-examining the second most abundant molecule on Earth, H2O, or water. At standard pressure, 14.69 pounds per square inch, water exists as a solid at 0 Celsius or below, a liquid when between 0 and 100 degrees Celsius, water, and a gas when above 100 degrees Celsius. But can we make the water hotter than 100 degrees Celsius and yet not have it convert to a gas? Well, the answer is, yeah, we can. We just have to change something. The first way is to change water's formula. Well, sort of. Technically speaking, the temperatures we've been talking about is for pure H2O or pure water, and that is very hard to find. The freezing and boiling points of water change with soluble impurities. The greater the impurities in the water, the greater the heat energy required to make it boil or freeze. This is why adding salt or butter to water temporarily stops it boiling. The new salt water needs more heat before it will boil again. This also explains why salt melts snow. The salt water will freeze at a lower temperature than fresh water. This also explains why fresh water freezes at 32 degrees Fahrenheit and yet salt water freezes near 0 Fahrenheit. The second way is to change the pressure the water is placed under. If you go mountain climbing, you will discover that water boils faster and easier the higher you go. This is because there is less atmospheric pressure on the water. The lower the pressure, the faster the heated water turns into a gas and boils off. However, the actual temperature of the water will be cooler than 100 degrees Celsius. Let's look at two extreme examples. At sea level, the average daily atmospheric pressure, the weight of the atmosphere you feel, is around 101.325 kilopascals. On top of Everest, the average atmospheric pressure is around 33 to 34 kilopascals. Now at sea level, we determine that to be 0 meters of elevation. In Mount Everest, the elevation is 8,848 meters. So at sea level, water converts to a gas, or boils, when its temperature is raised to 100 degrees Celsius. But on top of Mount Everest, you only need to heat the water to 71 degrees Celsius to begin to convert it into a gas. Since the atmospheric pressure on Everest is only 1/3 of sea levels, it takes a lot less heat to make water boil, and it boils more aggressively. Meanwhile, back at sea level, on the other hand, if you apply more and more pressure to water, something else happens. As you apply pressure, the water will not compress. Instead, it will absorb that energy by converting it into heat. As we have seen, this is why lakes or oceans do not freeze completely solid on Earth when the temperature is very cold. Oceans also have a lot of impurities like salt. Having said that, if the pressure is raised high enough, water will become a solid. It will freeze. When water solidifies this way, no amount of heat will melt it until the pressure is reduced. The graph on the right shows the phase or state of water for any given pressure and temperature. You could think of this graph as a sort of phase fingerprint. All matter molecules have their own pressure and temperature graph, or phase fingerprint. Take a close look at this graph. Notice that the pressure scale shown on the left is exponential, and the boundaries for each state is not linear. As mentioned earlier, this is water's phase fingerprint. The blue area shows the pressure and temperature combination where water is a solid. This graph is unique to pure water, and it shows the triple point in a series of numbers in the blue area. The blue Roman numerals indicate a unique, different form of solid water. When the pressure is above 10 gigapascals, water is a solid, and no change in temperature will melt or boil the water. This has been Physics in Minutes. Next time, more fun under pressure.